Hello, everyone, and welcome to NSTA Web Seminars, where you find live interactive learning at your desktop. My name is Flavio Mendez, and I will be moderating today's program. Michelle Phillips is online with us to provide technical support. Today's seminar is titled Science Update, Making Climate Science Matter, Expanding the Use and Reach of the 5th National Climate Assessment. Presenting today are Patrick Chandler, Elizabeth Payton, Anya Boschlowitz, and Quinn Adams. But before we begin, we would like to acknowledge our sponsor, then go over NSTA's virtual program norms. We'd like to thank the Vernier Science Education for sponsoring today's program. The National Science Teaching Association strongly supports diversity, equity, and inclusion in the classroom and in all of our programs. We are committed to providing a welcoming, safe, productive, harassment-free environment for all our participants of our events and programs, regardless of their gender, gender identity, sexual orientation, ability, ethnicity, race, color, age, marital status, veteran status, socioeconomic status, or religion. We ask that all attendees be mindful of their surroundings and of their fellow participants. All participants are expected to exercise consideration and respect in their speech and actions, and to refrain from demeaning, discriminatory, or harassing behavior and speech. NSTA does not allow promotion of other products in our chats during web seminars. We ask that attendees keep the conversation on topic, use positive language, and remain courteous of others throughout the event, and allow everyone time to participate in the chat. It is now my privilege to introduce today's presenters. I'll start with Patrick. Patrick Chandler is an education specialist for the Climate Literacy Energy Awareness Network and other Cooperative Institute for Environmental Sciences climate education projects. His current focus is developing support and resources for teaching climate change across the curriculum in both science and non-science classrooms. Patrick has over 15 years working in and developing environmental education, art, stewardship, and science programs, and received his PhD in environmental studies from Colorado University Boulder, focused on art and science partnerships to catalyze community action on environmental and social justice issues. I'd like to introduce Liz Payton. Elizabeth Payton has an MS in civil engineering from Colorado University Boulder and is a water resources specialist with the Western Water Assessment. She works with water users in the WWA region to access and understand climate and hydrology information. Liz is the water chapter lead for the recently released 5th National Climate Assessment. I'd like now to introduce Anya Boschlowitz. Anya is a graduating senior at the University of Colorado at Boulder, studying environmental studies and atmospheric and oceanic sciences. Her interest in environmental studies stems from her passion for preserving and protecting the environment through education and community outreach. Finally, Quinn Adams. Quinn Adams is an environmental studies and ecology student, graduating in the spring of 2024 at the University of Colorado at Boulder. Quinn is interested in cultivating resilient systems through sustainable development and community-based initiatives. And presenting first today is Dr. Patrick Chandler. Welcome, Patrick.
Thank you so much, Flavio. I'm going to jump in just briefly here to provide an overview of what we have planned for the day. Liz Payton is going to start us off with a discussion of the National Climate Assessment and taking a look at the 5th version, what's the same, what's different, and highlighting the chapter that she worked on, Chapter 4 on water. Then I will jump in briefly to tell you about our project with the Climate Literacy and Energy Awareness Network, focused on creating an educator's guide to support the 5th National Climate Assessment. And 2 students who have been working with me throughout this spring on that guide will present a couple pieces of it, focusing on the guiding questions, lessons, and videos, and the classroom level climate actions. And we'll finish up with a round of questions on everything we cover today. After Liz is finished speaking, we'll take one or two questions, have about 5 minutes there. And again, after Anya and Quinn. So please, for those sections, make sure your questions are applicable to the speaker who just spoke. And then we'll wrap up with questions at the end. And without further ado, I will pass it to Liz. You're muted, Liz.
So sorry about that. Yeah, I had everything all lined up, but except for the mute button. Okay, so anyway, thank you so much for the opportunity to speak to you today. And I'm here to give you an overview of the 5th National Climate Assessment, or NCA5. Hopefully you can see my cover slide of the 5th National Climate Assessment. Just holler if it's not showing up. The National Climate Assessment is a quadrennial report prepared and submitted by the U.S. Global Change Research Program, or USGCRP, and it's submitted to Congress and the White House. The USGCRP is a group of 12, I think, agencies that support the support and guide the USGCRP. I'm speaking for myself today and not for the USGCRP. So as Flavio said, I'm a water resources engineer by training, and I do climate and hydrology work at Western Water Assessment, which is a NOAA-supported applied research climate action partnership. It's one of 12 such teams across the country. And Western Water Assessment is hosted by the Cooperative Institute for Research in Environmental Sciences, or CERES, at the University of Colorado Boulder. And we serve the Intermountain West, so the states of Colorado, Wyoming, and Utah. We work with communities and decision makers in the region to provide access to usable climate science, data, and tools. The NCA5 is written by over 500 authors and 260 technical contributors. Throughout the two-year 6-draft process, there were multiple opportunities for public engagement and comment. There was an extensive review process, including peer review, coordinated by the National Academies of Science, Engineering, and Medicine. This slide shows the table of contents, showing the physical science chapters, sector chapters, and regional chapters, and the response chapters. My chapter is the water chapter over here, and it covers the entire nation, climate change impacts to water across the entire nation in just a very short 5,000 words. So if you want more detail about your part of the country, please be sure to check out the regional chapters here. They are quite a bit longer than the water chapter, and they offer a lot more detail about the individual regions. So the NCA5 reflects some of the refinements that have been made as the needs for information have changed over the years. So there are 2 new chapters that weren't in previous NCAs, the economics chapter and the social systems and justice chapter. There are focus features on these 5 topics, and there's a new appendix called the Indicators Appendix, which is really a fabulous resource, and I hope you check it out. Another new feature of the National Climate Assessment is the inclusion of art submitted through a competition run by the USGCRP team. There were separate adult and youth competitions, some of which are shown on this slide. A few of the youth entry winners are shown in the bottom row. And on the art gallery page, which I'll show you a bit later, you can read the artist's statements about their work. The statement for the watercolor that has the manatees and that's by a 11th grader. And it says, in part, I wanted to depict manatees in their usual habitat, peacefully swimming through the water. We should be taking steps in order to coexist with sea life without causing them harm. We should be working to protect sea life, to respect their environments instead of damaging them. I hope that I can bring awareness to this issue and inspire better appreciation for marine life. So I hope that you take a little bit of time sometime to go through the gallery, and I'll show you where that is, and read the artist's statements. They're very interesting and heartfelt and often about their local areas and just really inspiring. So that leads us to the water chapter. The cover image for our chapter is this painting of Lake Mead on the Colorado River and the so-called bathtub ring by John Bradham, and is titled Drought's Edge Illuminated. I'll talk a bit about our chapter development process, some of the chapter findings, and then take you on a brief tour of the NCA website. As water chapter lead, I was able to build my own author team. I recruited this brilliant group of experts from local, private, academic, and federal organizations from all over the country. We had state climatologists from Vermont and Nevada. We had a Navajo citizen water law professor. We had experts in snow, flooding, groundwater, drought, municipal utility, water quality, and climate modeling. And the authors and I met every other week for about 2 years. So we really got to know each other, and we spent a lot of time working on this chapter, refining it, making sure that it was relevant and useful. We started by the writing process by identifying as a team the questions we wanted to tackle in the chapter. And with our limited word count, we couldn't cover every water-related climate change topic. So the water chapter focuses on terrestrial freshwater. These discussions guided the scope, findings into these 3 key messages. The first key message is about the trends and projected changes in water cycle components. The second key message is about impacts of those changes. And the third key message is about adaptation to the changes. The full text of each key message is in the chapter, and I won't read it to you here because it's quite long. So I'll start off with the evidence base for key message 1. And the way I have organized this is I'll first describe observed trends and averages, then observed trends in extremes, followed by projected changes in averages and projected changes in extremes. So this figure is from chapter 2, the climate trends chapter, and it shows how average annual and seasonal temperature and precipitation have changed since the first half of the last century. So temperatures on the left with the annual winter and summer change since the first half of the last century. And temperature is on the left, annual winter and summer. And you can see in the temperature that it's mostly red, meaning that the temperatures have gone up. Precipitation on the right shows, especially in summer, a lot of decrease in annual precipitation in the west and increase towards the central part of the country and the east. But you'll also notice this sort of blue area, a little bit of cooling that has been observed in this part of the country in the summer, and that corresponds to areas where there has been increasing precipitation. This group of figures from the indicators appendix shows observed changes in snowpack in the western US, where we are heavily dependent on snow for water supply. Snow is a good indicator of climate because it has direct sensitivity to both temperature and precipitation. These figures show observed changes in 3 snowpack metrics: snow water content, timing of peak snowpack, and length of the snowpack season. The size of the dots indicate the degree of change, and the color indicates the direction of change. Orange means decreasing and blue means increasing. And all three metrics show a general trend toward reduced snowpack. The average decline in water content has been 23%. Peak snowpack is 8 days earlier on average, and snowpack season length is 8 days shorter than average. Shorter on average. So let's shift then to observed trends in extreme conditions. This figure shows observed changes in heavy precipitation since 1958 using 3 different types of metrics. Total precipitation on the heaviest days is on the left. The 5-year maximum precipitation in the center, and the annual maximum daily precipitation on the right. You can see large regional differences in both the rates and the direction of change in these figures, with increases in heavy precipitation amounts almost everywhere, but especially large increases in the Northeast. Here it's increased by 60%, and decreases in the Caribbean and Hawaii, with Puerto Rico having lost, their heavy precipitation events have decreased by 24%. Shifting to the other extreme, the green areas represent observed trends toward wetter conditions, and the brown areas represent trends toward drier conditions. More drought has been occurring in the southwestern US, with wetter conditions in the center and northeastern parts of the country. So far, we've looked at observed changes across the nation. This slide shows climate model projected changes by mid-century in average conditions. For teachers, it might be interesting to think about ways to use figures like these, given that the units are all inches, and so they're comparable instead of being in percentages, though the scales do differ from figure to figure. Precipitation is in the upper left, showing that most of the US is expected to see increases in annual precipitation, with decreases focused mostly in the Southwest and Hawaii. Snow projections are in the upper middle, showing that despite increasing precipitation, the future climate will have decreases to snow, essentially everywhere except parts of Alaska. Actual evapotranspiration, or ET, is shown in the upper right. ET is the amount of water that evaporates from soil and surface water or transpires from plants. And actual ET increases as temperatures rise, but only if there's enough water available to meet the thirstier atmospheric demand. So the map shows expected increases in actual ET in most of the country, except in the Southwest and the Southern Great Plains, where there's expected to be less water available to be evaporated or transpired. The next water cycle component that we address in the water chapter is soil moisture, and particularly summer soil moisture, so June, July, and August. And it's critically important for agriculture and ecosystems. And the projections from climate models show that, with the exception of parts of the upper Midwest and Alaska, summer soil moisture is expected to decrease due to warmer temperatures, driving increased atmospheric demand for moisture. And not shown here is a map of projected groundwater levels. Groundwater levels are very dependent on the amount of pumping and recharge, but are generally expected to decrease with warming. The last of the hydrologic component maps is the projected annual runoff in the lower right. And runoff is the water that makes its way to rivers, lakes, and streams over or under the land surface, and integrates the changes we see in these other hydrologic water cycle components. And the models show projected increases in runoff for most of the country. But if you look at the scale, you could see that these projected increases are very small. on the order of 1/10 of an inch. And that's demonstrating that the annual precipitation, this up here, is projected to increase by a full inch or more in much of the country. That increase is offset by climate change impacts to the other water cycle components. So those were the projections of average conditions. This figure shows projected changes in extreme rainfall events with the same metrics that we saw for the trends in extreme rainfall. Except for parts of the southern Great Plains and Southwest, there are very few areas that are projected to avoid increases in extreme precipitation events. For future drought conditions, we used a metric called the projected climatic water deficit, which is the shortfall of water necessary to fully supply vegetation requirements. And it is the difference between the potential evapotranspiration and the actual evapotranspiration. So it shows that vegetation needs will increase with temperature, and without a compensating increase in precipitation, the deficit is projected to increase. The next set of slides here are part of the evidence base for key message 2 about the impacts of the changes that we just saw in the water cycle. This figure shows cumulative inland flood damages across the US in gray, and the estimated portion due to changes in precipitation in green. And there have been $230 billion in cumulative damages, of which about 1/3 can be attributed to increasing precipitation. And that's since 1990. Drought impacts have also been significant. Between 1980 and 2022, drought and related heat waves in the US caused $335 billion in damages. In addition to agricultural losses, droughts put river and lake transportation at risk and are important factors in the loss of ecosystems. There are multiple types and effects of drought, and this is an example from our chapter with in this example, there was a warm winter, the water year 2015 in the Pacific Northwest, and that warm winter caused much of the precipitation to fall as rain instead of snow, producing a reduced snowpack, which then led to early snow melt and resulted in low stream flows during the irrigation season. So this particular crop was an apple orchard, suffered the effects of that warm snow drought by not having enough water to irrigate the trees. And drought has and is likely to continue to drive increases in groundwater pumping. Groundwater pumping can reduce surface water supplies. And one example is the San Pedro River in Arizona, where pumping that began in the 1940s, has deprived wetlands and wildlife habitat of fresh water. Climate change also affects water quality, and changes to ambient temperature, sea level rise, and precipitation have these cascading effects on climate hazards, increasing the hazards, and then resulting in these negative water quality outcomes. These water quality issues fall disproportionately on frontline communities. Older adults, children, and residents of low-income neighborhoods and rural areas are at greater risk of exposure to pathogens and pollutants from climate change-driven impacts to water quality. Continuing with about the frontline communities and climate change impacts on them, people who live along coasts and rivers or who work in agriculture and fisheries have increased exposure to water-related hazards. Neighborhoods that are home to racial minorities and people with low incomes have been shown to have the highest inland flood exposures in the South. This slide shows the projected future average annual loss from floods across the US between now and 2050. The national average annual loss from floods is expected to increase by about 26% between now and 2050. But there is a much greater projected increase in losses in Black neighborhoods. Hurricane Harvey occurred in 2017, and there have been more disastrous floods since then. But the time in between has allowed scientists to examine the climate change component of the event. There are more than $150 billion in damages and more than 100 fatalities. Scientists have used attribution techniques to determine that climate change increased the amount of precipitation by 15 to 20% for that event. And they've also determined that the flood extent was 14% greater than expected with climate change, resulting in 32% more homes being flooded. Many of the homes were outside the FEMA 100-year floodplain and thus were uninsured. And those homes were disproportionately occupied by Blacks, Hispanics, people with disabilities, and people receiving subsidized housing. And of course, drought can also have unequal impacts depending on economic sector, access to water resources, ability to irrigate, reliance on electricity, and socioeconomic status. So drinking water infrastructure is also aging and deteriorating, compounding issues with water supply and degraded water quality, especially for frontline communities. This figure shows the numbers and locations of homes requiring sanitation facility improvements within the Indian Health Service areas. The deficiency levels range from minor deficiencies indicated by the lighter colored dots and to the more severe dark purple dots that indicate homes that lack a safe water supply and sewage disposal system. And that brings us to the last key message, where we discuss barriers and progress toward adaptation. Uncertainty from natural variability has always been part of water resources planning, but as climate change affects different components of the water cycle, uncertainties around extreme events and water availability have increased. Responses to these growing uncertainties include a wide range of climate adaptation and hazard mitigation efforts. One of the barriers to adaptation is simply the natural fluctuations in wet periods and dry periods, wherein the urgency to act waxes and wanes with current or recent conditions. This figure shows natural variability in the Colorado River. This is the Colorado River at Lee's Ferry, Arizona, just below Lake Powell and above Lake Mead. And it shows that the river was high during one important policy event, which is the Colorado River Compact, and that the river was low during shortage negotiations. So you can see how that kind of fluctuation affects the people's attitudes towards how much water is available for allocation. And the two maps above show, they correspond to these same periods, and they show the upper Colorado River Basin outlined here in orange and here in black, and it shows the basin in two different decades, the decades corresponding to when these policy events were negotiated. And in the earlier decade, the Colorado River Basin is relatively wet compared to the rest of the country. And in the later decade, the Colorado River Basin is relatively dry compared to the rest of the country. So we have this natural variability across space and time. And then this figure shows this historic observed streamflow record superimposed on a reconstructed paleo record from tree rings. While progress toward adaptation has been uneven, examples exist where water resources policymaking and planning are advancing. The Great Lakes, which contain the largest quantity of surface fresh water on Earth, are shared by 2 Canadian provinces, 8 US states, and many sovereign tribes and First Nations. Together, the parties have implemented a new management plan to resolve water conflicts while restoring ecosystems and accounting for climate change. And data are foundational to adaptation. Water resources planning in many sectors and locations continues to be informed by past hydrologic records that do not reflect the impacts of climate change. So part of the good news is that the National Climate Assessment has provided an atlas that gives county level projections of multiple extreme precipitation and temperature metrics, like those shown on this slide. And I'll show you the whole thing in a minute. I will navigate over to that. So, and these are some other National Climate Assessment resources that I'll go through here as I give you a little tour. So, okay, so you should see my desktop with the National Climate Assessment homepage on it.
We do.
Okay, great. So when you visit the NCA 2023 globalchange.gov, and this is what will come up, and you can see all of the chapters here that I showed you, the table of contents, and here's the water chapter. You can click on any of those. You can see information that's downloadable. So you can download, let's see, here we go. Handouts, all of the slides, all of this is public domain. So you don't have to worry about copyright or anything like that. And you can download the full report or individual chapters, figures, slides, lots of information there. The Art by Climate tab will take you to the art gallery, which I've got loaded here, so it'll be faster. And here are some of the images, the artworks. They're really wonderful and interesting. The entire report has been translated into Spanish for folks who have who would find that useful. And the atlas is let's see, here's the atlas. And I kind of preloaded stuff so that we wouldn't have to wait while things load. But if you click on the home tab here for the National Climate, for the Atlas, you get this screen. If you click on Open the Explorer, you get this screen. And then you can pick a map that you're interested in, like, for example, the number of days, change in number of days over 105 degrees. And this is, yeah, here you go. So you can pick what layers you'd like to show on the map. And I'm going to just show the 2-degree warming map because that one is the one that seems to be the most likely. You can zoom in to any part of the map, and you can even go, to your own county and look and see what the climate models say about your particular location for this particular metric. So for the change in number of days over 105 degrees for Hall County, Texas, is projected to increase by 15 days compared to the previous last decade. And that's at 2 degrees centigrade warming. So this is a very helpful, handy tool, and has lots and lots of information. And you can download the data, or you can use the maps directly. It seems like it would be a really helpful and useful tool for teachers. And then the last thing I wanted to show you was the water chapter, and how you can get information from the figures. So if you're working with students and they need to know where the data came from, or if they want to try to use some segment of the data or reproduce the figures or something like that, we have these icons for every figure. This one takes you to the atlas. This one makes it possible to download the figure. This one, it takes you to the metadata. And the metadata is just encyclopedia of information. For every figure, every map has information about the extent, who made the figure, all the files that went into building the figure, the assumptions behind the figure, like, and methods, all kinds of stuff. So, and that's for the, you know, the entire report. So that is the end of my, let's see, hang on a second. And there, that's the end of my presentation. And this slide shows a link to the full report, to the full report down here, and then my chapter, the water chapter, and my contact information. So that's it.
Thank you so much, Liz. Really
You're welcome.
appreciated the overview and
Yeah,
more
sure.
information about your chapter. We're
Mhm.
running just a little bit behind, so
Okay.
I want to not do questions live. We'll take questions in the chat, and we'll also have about 10 or 15 minutes after, where a few of us will stay and take questions then. So maybe
Yeah.
if you'd be so kind, Liz, is to jump in the chat and answer questions if you can. And otherwise, thank you for posting questions there, and we will keep moving with the presentation. So I want to give you just a very quick overview of the project to take the 5th National Climate Assessment and create a resource for educators that they can jump right into. But before I do that, I want to mention that this project is working through the Climate Literacy and Energy Awareness Network, or CLEAN. And CLEAN has been around for about 14 years. And over that time, we've reviewed over 40,000 resources. And through a very rigorous review process, we've taken about 1,000 of them into our collection. So we've got an all collection of climate education resources. We have teaching guidance for using those resources and working through topics in the classroom. And we have an amazing community of practice. If you go to our website, which is cleanet.org, cleanet.org, you'll see that you can find the collection here, the teaching guidance here, and the ways to get involved there. We're also syndicated on climate.gov, so you can find us there as well. And the most amazing thing I think about Climate Literacy and Energy Awareness Network is our review process. We work really hard to make sure that what's included in our resource set is really classroom ready and of excellent quality. So if you're interested in any of this or would like to learn more, please let me know, and I'm glad to provide more information. For this project, we focused on the NCA5 and created an educator's guide based on the 10 regional chapters for the United States. In each chapter, we took the key messages to create guiding questions and then provide resources for those questions. And Anya is going to be speaking a bit more about that. We also included art and figures from the assessment, and then looked at classroom level climate action. And Quinn is going to be speaking more about that. You can find this under our tools for educators on the website, and get into each regional chapter. And if you'd like to know when this is finalized, please join our network. We've got everything drafted right now, and we'll have it up on the website by the end of May. So it's not quite ready for your use just yet, but will be in the coming weeks. So please join our listserv or our network to get more information. And with that, I'm going to pass it to Anya to talk a little bit more about the guiding questions portion of our educator's guide. Okay, and we're going to switch out very quickly here. I'm out. Anya's in. Here we go.
Hello, everyone. Okay. So I'm going to be talking to you today about the guiding questions in our lessons and videos. So first, our guiding questions promote critical thinking. They are written to encourage individuals to explore the topic further, and students can actively think through the problem as they seek answers and solutions. And it might also encourage students to think outside the box. Additionally, these questions are really good for encouraging discussion in and outside of the classroom, so you can have students discuss these questions and compare their answers. This can encourage more engagement. And lastly, they can provide direction. The National Climate Assessment is a pretty large document and covers a lot of materials. So this is a good way to check in with students as you're going through and make sure that they understand the topics being discussed. So our process for writing our guiding question involved first reading through the key message overview. This is a screenshot of our Northeast chapter, chapter 21. This is the key message overview. Just gives brief information about what the key message is going to be about. And then as we're reading through the key message, we are identifying the themes that we find important, and we are compiling 9 to 10 questions. And then later we revise and we make sure that like the sentence structure is diverse and they are engaging and make sense. And then we will select the top 3 questions as a group. So here's an example guiding question. The guiding question is, how do land use choices lead to more extreme weather event impacts in urban areas? How can land be developed to prevent/reduce extreme weather impacts? And this is coming from chapter 21, Northeast Key Message 1, which covered a lot about chronic weather impacts in the Northeast area. And so our lessons and videos, we selected them from Clean. We selected a lesson and video for every guiding question. So all of the lessons and videos, or most of the lessons and videos came from Clean, which, as we said before, go through a review process and are ready for the classroom. So our lessons and videos are a good way for students to apply their knowledge in the classroom. They can also be used to encourage creative and critical thinking. And then they can also be used as an assessment tool, or again, as a way for you to check in on students' understanding of the material. So for our example lessons and videos, each include a description, just a brief overview on what you can expect. And then for the lessons, we also included the instructional time and the grade level. And then for the videos, we included the video length. So all this information is easily accessible as you scroll through the guide. So let's go over an example lesson. The guiding question is, what are some impacts to agriculture and locally available foods due to extreme weather impacts? And so here is an example lesson that we would select for that. As you can see at the top, you have the title, which is the effects of climate change on agricultural systems. You have the author italicized there, and then you have the link to the actual lesson. And then highlighted here, you can see the description. So as you're scrolling through, you can easily read what the lesson is about and what you can expect. You will also see the instructional time. So for this example, it will take, this is a set of 5 learning activities and will take around 2 45-minute class periods, and then the grade level. And so example video, again, pretty similar format. This one is on fisheries, and as you can see, it's we have the description again and the video link. And so really our goal for this project was to create an adaptable climate-ready resource set. And so all of our resources can be adjusted for grade level. So say you find a lesson that you really want to teach, but your grade level doesn't match the recommended one in the guide, you can definitely go through and adjust to make sure that it's more suitable for your classroom environment. Same with the amount of instructional times. Some of the lessons can take longer, but can be shortened if you have less time. And additionally, they can be lengthened using supplemental resources that we have also included. Same for the videos. Some of them are a little bit long, but you can definitely go through and only watch parts of it. And then lastly, you can control the amount of engagement that you get in the classroom, all depending on which resources you pick and which topics you want to discuss. So that is all I have for you. Sadly, there isn't any time for questions, but we will take those at the end. Thank you.
And please ask Anya questions in the chat if you have them, and we'll get those answered in real time. And now, as a disembodied voice, I will introduce Quinn.
Hey everybody, my name is Quinn, and today I'll be talking to you about how we supplemented our teaching resources with actionable steps. So, in the recent years, we've noticed that there's an increase in the phenomenon of climate anxiety in school-age children. This is bad for a couple of reasons. For one, climate anxiety can be very debilitating and have negative impacts for student health and well-being. And then also climate anxiety can inhibit action on climate change. And the way to combat this is by providing actionable steps for students to actually engage with climate change in a way that's positive. When students have access to these steps, they feel like they have more agency to actually make change, and that makes it less hopeless for students. So this led us to develop our Pathways to Action guide. You can find the Pathways to Action under the key messages for each of our chapters. In the Pathways to Action guide, we include actions and case studies that highlight ideas for climate change adaptation and mitigation at multiple scales. These guides, for each chapter, we have 4 actions. Each action includes a solution overview, a classroom level action, and a regional case study. And I'll go into those on the next slide. So this is an example of what you might expect from the solution overview. We typically get our solution overviews from Project Drawdown. We found it's a great resource as it has a comprehensive review of a solution that's being implemented across the nation. And we really like Project Drawdown because they do a really good job of explaining the science that allowed them to arrive at their solution. In cases where we don't use Project Drawdown to inform our solution overviews, we'll use a different resource that is equally reputable, and we'll look for a resource that explains the science just like Project Drawdown does. So continuing on, this is the second part of our Pathways to Action guide for the Northern Great Plains. This is action 3, which is reducing agricultural impacts. On the left, you can see the regional case study. The regional case study we chose for this action it shows how a local farmer is implementing climate smart technology to decrease the agricultural impacts that his farm has. We really like these regional case studies because they provide students with a solution in a context that they're aware of because they've grown up around the areas that the solution is being implemented. Typically for these regional case studies, we'll look on the U.S. Climate Resilience Toolkit. That's a really great resource because they have lots and lots of solutions for various areas of climate change. On the right, you can see our classroom scale actions. For these, we make sure to adapt actions to fit within the classroom. Highlighted in green, you can see some actions. These are from Drawdown Eco Challenge. We really like Drawdown Eco Challenge because they provide a range of actions suited for individuals that allows them to take steps to work with climate change. And an important thing to note for these classroom scale actions is that we often have to adapt them from an individual format to be applicable in the classroom. So that leads me to my next point. While we were looking for our pathways to action, we realized that there's a gap in the classroom resources that are available. We saw that there are many individual actions, such as putting solar on your roof. And we also found a wealth of community level actions, such as creating a solar wind farm. However, we found very few actions that were tailored to fit the classroom. And this provides a challenge for teachers because it's hard to give students the actual context of action if students can't participate in some form of action themselves. And because of this, we decided to create our classroom scale climate action guide. This is a guide that presents 5 to 8 actions for each of the categories you see here. The categories are forest fires, floods, drought, extreme heat, and engaging with policy. We chose to focus on hazards for our climate actions guide because we found that these hazards were themes that consistently came up throughout the NCA5 as we were reviewing it. And so having a resource with actions that target each of these makes our actions widely applicable throughout the different regions. Another benefit of focusing our action guide on hazards is that this is easy for teachers to engage with their classroom about. They can easily go out into on their campuses and make changes that increase their school's resilience to each of these hazards. An additional reason why we decided to focus on hazards is because focusing on hazards takes the issue of climate change out of a politicized zone. So teachers don't have to worry as much about parents or family being upset by their students taking action to minimize things that pose a risk to the school. So I'm going to present some examples from our classroom scale actions guide. This first action is from our floods category, and the action is installing rain barrels to reduce flooding. For each of our actions, we'll provide a short description as well as supporting resources showing how teachers can implement this action at their classroom. The second example is for our engaging with policy category. This action is having students research local policymakers as well as policies in their region. And the thinking behind this is that by empowering students to know what policy is in place surrounding the climate, it gives them more agency to act or advocate for more climate policy or whatever they feel called to advocate for. So with that, I think I'll wrap up. We found through reviewing the NCA5 that it points to an urgent need for action, and climate education needs to match this need if we want to reduce students' anxiety about the climate and empower them to make change. And our classroom scale action guide, as well as the pathways to action, enable teachers to teach about actions in addition to the other climate resources we've provided. With that, I think I'll pass it over to Patrick, and then we'll get started with the question session.
Awesome. Thank you, Quinn and Anya. I see that we have time for probably one question before we wrap up this evening. If you would like to ask a question about anything that we covered tonight in the first or the second half of the presentation, please put it in the chat. We can get to that pretty quickly. We'll jump in and answer. And also, we'll stick around for a few minutes afterwards to make sure we're here for all questions that come up. I put a couple things in the chat. One is a link to the educators, or I'm sorry, to the Clean Network, which you can join to get informed about clean resources and when the NCA5 Educators Guide is published and up on the website. It should be available by the end of May. And as Flavio mentioned, there's a lot available through the NSTA collection from what we presented this evening. Including the websites, the links, and some resources. And Flavio posted the link to the Clean website there, which I'll post one more time here in case you should need it. All right. And I'm not seeing immediate questions come up, and I see we are at 5 till the hour. There's one question. We'll jump on that, then I'll pass it back to Flavio to wrap up this evening. We provide a paid resource to K through 12 classroom. Can we reference your resources? You are welcome to reference our resources, and that brings up something important that I didn't mention, which is all resources in the Clean collection are free. So for anything you find there, there is no charge, but we are open to being promoted anywhere you'd like to promote us to help teachers gain access to climate resources, as long as it doesn't cost them to do so, to access our links. So that's great. And there are other questions coming in. We might have time for one year. Liz, one more. Liz, would you like to jump in? Yep, she already answered it. How often is a new climate assessment released? About every 4 years, give or take. Anything more you'd like to say on that, Liz?
No, it's, they've just today released a call for nominations for authors. So that's something that anybody can nominate a friend or themselves to participate and in the National Climate Assessment. It's not paid, it's all volunteer, but it's a really interesting activity. So the USGCRP has a mailing list, and I would go to their website to look for that call for nominations.
Excellent. Thank you so much, Liz.
Sure.
Thanks again for everybody for being here, and to NSTA for facilitating this presentation and hosting this workshop. And with that, I'll pass it back to Flavio, and we will stick around for questions after the hour if anybody has them. Thank you.
Well, I'd like to first recognize our presenters, Patrick, Elizabeth, Anya, and Quinn. Thank you so much for your presentation. This is a very timely. You may know or not, we did a web seminar last week about precipitation, and we're looking at NASA data from the different observatories on satellites looking down at the Earth. So we did this strategically all around our celebration of Earth Day to bring a focus to our planet and to everything that we can do to inform educators and science enthusiasts. So thank you so much for your presentation today. I'd like also to thank our participants for their questions and attention, and also for sharing via the chat window, making it rich, not only for those here, but also who may be watching this program as a recording. As Patrick mentioned, the resources in the Clean website are all free to educators and everyone. So please feel free to share information, as well as please visit the report website as well, and read not just Liz's chapter, but also other chapters as well, sharing the information to as many friends, family, colleagues, etc. as you wish. The NSTA collection has links to it. I'll be placing that link in the chat window one more time. I'd like to thank our sponsor, Vernier Science Education, for sponsoring today's program. And I want to let you know that we do value your feedback. So please hang in there. In a couple of minutes, we'll be sharing with everyone the post-program survey link. We like to hear from you, your thoughts on today's presentation. Here's my cue to place the collection one more time in the chat window. A collection is essentially an electronic folder that we put together at NSTA for each and every web seminar that we do. So please check it out. This collection includes today's slides from our presenters, and also a list of resources that they compiled to share along with the slides. Making this folder is, you can share the folder forward with others who might be interested in the topic as well. They can click on it and it will lead them to all of those resources all in one easy location. So please do that if you desire. Opportunities coming up for those who missed our introductory presentation. We have more web seminars coming your way during the month of May and moving forward over the summer and fall. Visit the NSTA website to register for these programs on screen and many others that we have listed on our website. And please keep checking because we add web seminars to our list on a regular basis. Please know that NSTA is hosting the Fall National Conference in New Orleans on November the 6th through the 9th. So if you haven't registered, please do that and take advantage of the early bird. You also can register to participate in our upcoming book study in September through October, all about assessments in NGSS classrooms. So check that program out. I'd like to thank the NSTA Virtual Learning team for their support of NSTA web seminars. And with this slide, together we are the National Science Teaching Association. I'd like to conclude this program.